Not to do it again, there's no work for me.
All right. So with our equations, we looked at our two options of solving them yesterday, and we decided, okay, it is just easier if we get rid of the denominator.
Yeah.
Unfortunately, it doesn't work the same way with inequalities,
Gosh,
okay? Because, a couple different reasons. We are trying to decide greater than 0, if it's positive or negative. Both the numerator and denominator of the fraction impact that, don't they? If I want greater than 0, they both have to be positive or they both have to be negative. So we can't just ignore our denominator. If we think about like inequality rules, if you multiply or divide by a negative, what does that do to the inequality? Switches it. Can I just multiply by x plus 5? Do I know if that's positive or negative?
Yeah, it's positive.
Depends on what x is though, doesn't it?
Oh, well, I guess you gotta go time.
Yeah, if x is like negative 10, it would be a negative number. But if x is positive 10, it would be a positive. So we wouldn't know if we had to flip our inequality or not. So that's another reason we can't just multiply and get rid of it. So when we think about our graphs of rational equations, we know they have vertical and horizontal asymptotes, right? And we're asking where it's greater than 0, where it's above the x-axis. So what we are going to do, we could graph this entire thing, if you guys would like. You know, we can go through the whole bit, the x-intercepts, y-intercepts, vertical asymptote, horizontal asymptote, and then get that graph to decide if it's positive or negative. And that would certainly work. Or we can do what's called a sign line. For that to work, we have to have a single fraction on one side and 0 on the other. So it's set up kind of like we were getting ready to draw the graph. Then I need to know what makes both the top and the bottom of this fraction equal to 0. Because those are the places we can switch between a positive and a negative. Now when the top is 0 on my graph, that translates to the x-intercept. It's saying it would hit the x-axis at positive 3. When the bottom is 0, what is that on the graph? And what did we graph when we were doing this? When the denominator was 0, that's where we had our vertical asymptotes, right? So those are the places where it could switch between positive and negative. So it's using these aspects of the graph. It's just we don't have to find all those little details. Okay? We know we could have, you know, we could find our horizontal, we could have a graph up here, down here, we don't really know. So we're going to make what's called a sign line. It's just a number line, but we're just going to test out some points. So I'm going to put these two x's, my smaller one on the left, my bigger one on the right. Then we are just going to pick test points. Smaller than -5, so maybe a -6. Okay, I'm not actually plotting this, I'm just writing down what number I'm going to use. Something in between -5 and 3. What's a number in between -5 and 3?
0.
And what's a number bigger than 3? 4. Isn't that kind of what we did when we were graphing these things? And you know, we would find this one had a horizontal asymptote at 1. And we would plug in 6 or -6 to see if it was above or below this asymptote. That's what we're doing right now. All right, so if I put in a -6 and I'm plugging it into this fraction, I don't even really care about the number. I just care, is it a positive or negative? -6 minus 3 is negative. -6 plus 5 is negative. If you divide two negatives, you get positive. So that tells me this section was up here. Okay, if I put in a 0, 0 minus 3 is negative. 0 plus 5 is positive. A negative divided by a positive is a negative. So that tells me this one was down here. Okay, after 3, if I put in a 4, 4 minus 3 is positive. 4 plus 5 is positive. If you divide two positives, you get a positive. Okay. So we could have drawn the graph and looked at it, or we could just look right here. We want to know where this thing is greater than 0. Is greater than 0 positive or negative? Positive. So I want the positive section. So that's this and this. Or if I'm looking at the graph, this part of the graph was above 0 and this part was above 0. So you answer with the interval. So this is greater than 0 from negative infinity to negative 5, union 3 to infinity. So you can choose to draw a graph and find all the information like we were doing before, or all we really have to do is test points and check, is this positive or negative? All right. Questions on that? Let's look at this one. So 5 over x plus 4 greater than or equal to 1. All right. It only works if, like our strategy of sign line testing, things are positive or negative. We have to have a single fraction on one side, 0 on the other. So I'm going to have to start out subtracting over my 1. Okay. If you want to add or subtract fractions, what do you have to have? Common denominator. So this is like 1 over 1. If I want to get a common denominator, I have to multiply it by x plus 4 on top and bottom. So I have 5 over x plus 4 minus x plus 4 over x plus 4. All right, if I want to subtract that, we can make it a plus and distribute the negative. So when I combine like terms, I get 1 minus x over x plus 4 greater than or equal to 0. So we had a little more legwork this time because we had to get a common denominator, so we had a single fraction. Is that part? Okay. From here, we're ready to find our points on the sign line. So we have to set top and bottom equal to 0. So here I get 1 equals x, here I get x equals negative 4. So those are the points on my sign line. Those are the places where it might switch between positive and negative. So now we do test points. Give me a number smaller than negative 4. In between negative 4 and 1. And bigger than 1. I am plugging those into this fraction to decide if it's positive or negative. So if I put in negative 5, 1 minus negative 5, so 1 plus 5 is positive. On the bottom, negative 5 plus 4 is negative, so that section turns out to be negative. If I put in a 0, 1 minus 0 is positive, 0 plus 4 is positive. 2 positives make a positive. If I put in a 2, 1 minus 2 is negative, 2 plus 4 is positive, so that section is negative. Which ones did I want? Positives or negatives? Positive. How do we know that? Says greater than 0. Isn't greater than 0 positive? So that's this section. Now, this one says equal to 0. Equal to means bracket, but if I say negative 4 to 1, both with a bracket, my answer is wrong. Does anyone know why? Think back to yesterday. We talked a lot about what possible answers we could have. We talked about in a fraction, what can never happen. The bottom can't be 0. So x can't be negative 4 on this one, no matter what. because that gives me a 0 on the denominator. So negative 4 has to get a parenthesis. Even though it says equal to, the denominator gets a parenthesis no matter what. Only the 1 can get a bracket here. So negative 4 to 1 with a bracket on the 1. Let's try another one. Actually, I'm going to skip this one. I'm going to do them out of order. We're doing this one first. And I'll go back to my other one. All right. In order to solve these, we have to have a single fraction on one side, 0 on the other. So I'm going to start off subtracting my 1 over x plus 2 over. In order to add or subtract fractions, they have to have a common denominator, and these do. So we can put them into a single fraction. 7 minus 1 is 6. At this point, we set top and bottom equal to 0. Does 6 equal 0? No. So the only number I get is negative 2. So that's the only number we can put on our sign line. All right, so then smaller than negative 2, maybe negative 3, bigger than negative 2, so maybe a 0. These are my test points. Then we plug them in here. 6 is positive no matter what. Negative 3 plus 2 is negative. Positive divided by a negative. If I put in 0, 6 is positive, 0 plus 2 is positive. 2 positives make. Which ones do we want? Positives, because I said greater than 0. Okay, equal to means bracket, but can it equal negative 2? No, because it's from the denominator. So the denominator can't be 0. So it's just negative 2 to infinity. All right. I'm going to have you guys try a problem. This one's already set up like we need to solve the problem. We have a fraction on one side, 0 on the other. So now we need the numbers on our number line. So you set top and bottom equal to 0. And we solve. So if I add over my x, I get 5 equals x. If I subtract my 1, divide by 2, negative 1/2. So those are the numbers on my sign line. Okay, then you do a test point. So you have to have something smaller than negative 1/2, so maybe negative 1. Any number between negative 1/2 and 5, so maybe 0. And then any number bigger than 5. You are plugging these in right here. So if I put in a negative 1, 5 minus negative 1, so 5 plus 1 is positive. Negative 2 plus 1 is negative. A positive divided by a negative? If I put in a 0, 5 minus 0 is positive, 0 plus 1 is positive, 2 positives make positive. If I put in a 6, 5 minus 6 is negative, 12 plus 1 is positive, negative and positive make negative. Then we have to decide, do I want positive answers or negative answers? Less than 0 is negative, so that's this and this. There was no equal to, so we don't have to worry about what gets a bracket, everything's parentheses. So any number from negative infinity to negative 1/2, or from 5 to infinity, would make that inequality true. Or if you're thinking about the graph, that meant the graph was below the x-axis until -1/2, above the x-axis in between, and then below again after 5. Questions on that one? Let's do a couple more together. All right, our setup, if we want to just use that number line to test points, we have to have a fraction on one side, 0 on the other. So the very first thing I need to do is subtract my 4. If you want to add or subtract fractions, what do you have to have? Common denominator. This is like 4 over 1. So if I'm going to get the same denominator, I have to multiply by x minus 3 on top and bottom. So we get 4x minus 12 over x minus. All right, then what do we do? First, we have the common denominator, so now we need to put them together, don't we? So it's a subtraction, so I'm going to go ahead and make that plus and run a negative through. So I get 18 minus 4x, for x minus 3, greater than or equal to 0. So this is like the problem we started with last time. We're ready to find out what we need on our sign line. So you set the top and bottom equal to 0. So if we divide by 4, 18 over 4, or 9 over 2, or 4.5, and 3. When you make your number line, you have to go small to large. So 3 comes first, 9 halves is 4.5, so that's second. Test point. Give me any number smaller than 3.
2.
In between 3 and 9 halves.
4.
And bigger than 9 halves.
5.
I'm going to plug these in right here. So if I put in a 2, I get 18 minus 8, so that's positive. 2 minus 3 is negative. Positive and negative make negative. If I put in a 4, 18 minus 16 is positive. 4 minus 3 is positive. 2 positives make a positive. Put in a 5, 18 minus 20 is negative. 5 minus 3, positive. A negative and a positive, negative. Okay, now we have to decide which answer do we want. It said greater than 0, so greater than is positive. Equal to means bracket, but the denominator has to have a parenthesis because the bottom can't be 0. So the 3 has to have a parenthesis, the 9 halves could get a bracket. So it's 3 comma 9 halves bracket on the 9 halves. All right. How are we feeling? Is it getting better? I know it's a little bit harder than the equations. Let's do one more for today, okay? Last example of the day. Or I can make more examples if that's not enough. I would be happy to do that for you. Let's look at this one. We have to start by getting 0 on one side. If I'm going to add or subtract fractions, we need a common denominator. I have 2 fractions here. What does the first one need to be multiplied by? Top and bottom. What's the second one need to be multiplied by? the top, if I multiply that out, I get 4x minus 12. I'm going to leave my denominator as just x plus 1 times x minus 3. Second one, if I distribute my 2, so 2x plus 2. All right, if we're going to subtract, let's change this to a plus and run our negative through, and combine like terms. So 4x minus 2x is 2x, negative 12 minus 2 is negative 14. All right, now what? I have a fraction on one side, 0 on the other. Top and bottom equal to 0. If we set the top equal to 0, we get 7. The bottom, we get both negative 1 and 3. So on my sign line, I have more points this time. We have to put all 3 of them. Negative 1, 3, and 7. This is like a rational inequality that had multiple vertical asymptotes. So we need more test points. Give me something smaller than negative 1. In between negative 1 and 3. Between 3 and 7. And bigger than 7. Okay, we are plugging these in right here. You can use a calculator, you can do it by hand. I usually just talk through it. If I put in negative 2, negative 4 minus 14 is negative. Negative 2 plus 1 is negative. Negative 2 minus 3 is negative. If you have 3 negatives, your answer is negative. If I put in a 0, 0 minus 14 is negative. 0 plus 1 is positive. 0 minus 3 is negative. So that part would be positive. Put in a 5. 10 minus 14 is negative. 5 plus 1 is positive. 5 minus 3 is positive. So 1, that would be negative. And if I put in an 8, 16 minus 14 is positive. 8 plus 1 is positive. 8 minus 3 is positive. So all positives make positive. We wanted less than 0. Less than means the negatives. So this section and this section. No equal to, so everything is parentheses. So that would be negative infinity to negative 1, union 3 to 7. Are there any questions? There is a fairly short Math Excel assignment. I think it's 5 questions. If you had any problems with yesterday's, please ask me about that as well.